Welcome back sa aking channel. For today's video, I will discuss integration by substitution. So I just hope you already watched my first video about integration. So we use the u to the n du and integral of du over u. So this time we will discuss integration by substitution. Okay, so here are the problems that we are going to solve. So here are the 10 problems. So try to answer first before watching the video. Okay, so I will solve this in two ways using the simple substitution, and the other is by introducing the neutralizing factor. Okay, so let us answer number 1. Okay, so number 1. Integral of 3x plus 4 squared dx. So for this problem, we already discussed two formulas, the integral of u to the n du and the integral of du over u. So we will use these two formulas in solving the 10 problems. So u to the n du, the integral is u to the n plus 1 over n plus 1 plus c, and then if we have du over u, the answer is ln absolute value of u plus c. Okay, so for this example, so we will use u to the n du since we have exponent square. Okay, so by simple substitution, so we will let 3x plus 4 as our u, and then the exponent 2 is our n. Okay, so if we let u equals 3x plus 4, and then get the differential of both sides. So therefore, we have du is equal to differential of 3x plus 4 is 3 dx. Okay, then by substitution, so therefore this will become we let u as 3x plus 4, so this will become 3x plus 4, so that will become u squared, and then we have dx. So dx will become, we need to solve for dx, so divide both sides by 3. So therefore, we have dx is equal to du over 3. So therefore, we have integral of u squared times du over 3. So we have constant 1/3. So we just move this outside the integral symbol. So therefore, we have 1/3 u squared du. So apply now the formula u to the n du is u to the n plus 1 over n plus 1. So therefore, the integral is equal to 1/3 times u to the 2 plus 1. So we have u cubed over 3 plus the constant of integration c, and then substitute the value of u. The value of u is 3x plus 4. So therefore, the final answer is, and simplify the denominator, 3 times 3, so that is 9. So therefore, we have 1 over 9 times the value of u is 3x plus 4 cube plus c. Okay, so this is the final answer. Another way to solve this is by introducing the neutralizing factor. So same concept, we will let u as 3x plus 4, but okay, so let's rewrite. Integral of 3x plus 4 squared dx. So if we let u is, again, we have 3x plus 4, and differential du is equal to 3 dx. So as you can see in our original expression, integral of 3x plus 4 squared, so we have 3x plus 4 squared times dx. But our differential is 3 dx. So it is the same if we will multiply this expression by 3 dx over 1 over 3. Okay, so this is the same as 1/3 integral of 3x plus 4 squared, and then we have times 3 dx. So 1/3 times 3, so that is the same as 1. Okay, so we put 3 dx, and then 1/3 is 1/3 outside the integral symbol because our du is 3 dx. So 1/3 here, this is called the neutralizing factor. So usually the neutralizing factor is the reciprocal of the constant in the dx. So neutralizing factor is, we have 3 dx, so neutralizing factor is 1/3. Okay, so the first solution is by simple substitution. So the second one is by introducing the neutralizing factor. If our differential contains constant, so the neutralizing factor is the reciprocal of the constant 3. So we have neutralizing factor equals 1/3. So therefore, it is now in the form u to the n du. And then we have 1/3. Just like this in the first solution, we have 1/3. Okay, so now we can solve directly. So if we multiply 1/3 and then 3dx, so therefore the answer now is, it is now in the form u to the n du. So therefore the answer is 1/3. So no need to substitute the u because it's already in the form u to the n du. So we have 1/3 times 3x plus 4 cube over 3 plus c. And then just simplify, so we will get the same answer like this, 1 over 9, since we have 3 times 3. So 1 over 9 times 3x plus 4 cube plus c. Okay, so two different solutions using the neutralizing factor, and the other is by simple substitution. Okay, so next, number 2. Okay, so number 2, so we will let u as, oops. This is our u. So usually the value of u is the base of the exponent. Since we have x squared minus 1 raised to the 4th power x dx. So this will become our u. So let u equals x squared minus 1. Okay? And then our differential is equal to, our differential is differential of x squared. So that is 2x. Differential of negative 1 is 0. So we have 2x dx. So as you can see, we have x dx here. So there is no 2. So therefore, we have neutralizing factor of the inverse of 2 or the reciprocal of 2. So that is 1/2. So therefore, this can be changed into, we multiply 1/2. So we have 1/2 integral of x squared minus 1 to the 4th, and then we will multiply the 2x dx. So we have 2x dx. Okay, so again, it's now in the form u to the n du. Okay, so this is our u, this is our n, and this is our du 2x dx. Okay, so u to the n du. Then we have 1/2 here. So therefore, the final answer is equal to 1/2, and then just add 1 since it is in the form u to the n du, or u to the 4th du. Okay, so it's now in the form u to the 4th integral of u to the 4th du. So therefore, the u is x squared minus 1. So we have x squared minus 1 to the 5th power over 5 plus c. So the final answer is 2 times 5. So we have 1/10, and then x squared minus 1 to the 5th plus c. So if we use the other if the other solution is just solve for x dx, so x dx will become x dx is equal to, divide this both sides by 2. So therefore, we will get x dx is equal to du over 2, and then factor out the, or move the 1/2 outside, so the same as this. Okay? Okay, so next, number 3. So number 3, we have integral of sine to the 5th 4x cosine 4x dx. So in this example, we will always let u as the base with the exponent. So our exponent here is to the 5th power. So our u here is the base of the exponent. So we have sine 4x. Because the derivative of sine is cosine. Okay? So let u is equal to sine 4x, and then our du, differential of sine 4x, so that is equal to derivative of sine is cosine 4x, and then times the derivative of 4x, is 4. So we put the constant 4 in front. 4 cosine 4x dx. Okay? So it is now in the form, so this is our u to the n, this is our du. Then we have 4 neutralizing factor of the inverse of 4, that is 1/4. Okay, so we can multiply multiply out the neutralizing factor. So we have 1/4 integral of sine to the fifth 4x and then cosine 4x, then times, we will put 4 here. So we put the 4, sine to the fifth 4x times 4 cosine 4x, 4 cosine 4x dx. Okay, since the derivative of du is 4 cosine 4x dx, so 1/4 times 4, so that is the same as 1. Okay, so now it is in the form u to the fifth. So it is in the form u, this is our u, the sine 4x, and then to the fifth, and then this is our du, u to the fifth du, then we have 1/4 integral of u to the fifth du. Okay, so by simple substitution, this will be the answer, 1/4 integral of u to the fifth du. But idadiretso na natin. So therefore, the final answer, our u is sine 4x. So therefore, the answer will be 1/4 times our u is sine 4x. So we have sine 4x and then to the fifth, add 1. So we have sine to the 6th 4x over 6 plus c. So final answer, we have 4 times 6. So that is 1/24 sine to the 6 of 4x plus c. Okay? Final answer. Next, number 4. So integral of 4x cubed plus x times square root of 4x squared plus 1 dx. So in this type of problem, we want to use the u to the n du. So therefore, we will let u here. U is the 4x squared plus 1. And our n is the radical sign square root, that is square root that is equal to 1/2, exponent of 1/2. Okay, so exponent of 1/2. So 4x squared plus 1 dx. Okay, so for this, let us factor out. We have 4x cubed plus x. So let us simplify first. So this will become, simplify first, we can factor out x. Okay, so factor out x. So we have x times 4x squared plus 1. Okay, same as this. 4x times 4x squared plus 1. And then we have another 4x squared plus 1 square root. So that is equal to exponent of 1/2 dx. So this term 4x squared plus 1, so the exponent of this is 1. So by using law of exponent, we can combine this because we have the same base, 4x squared plus 1. So add the exponent, 1 plus 1/2, that is 3/2. So therefore, we have integral of x, and then we have 4x squared plus 1 raised to 3/2 dx. So now we will let this as our u. Always let u as the base, the expression that has exponent. So this is the base, 4x squared plus 1. So this is our n. So if we let u is equal to 4x squared plus 1, our differential du is equal to 4x squared plus 1. The differential is 8x dx. So we have expression of x dx. Okay? We have x dx. So therefore, we have neutralizing factor of the inverse of 8. So that is 1/8. Okay? So this can be expressed as, we have neutralizing factor 1/8 integral of, we have 4x squared plus 1. So that is our u. 4x squared plus 1 raised to 3/2. And then we have x dx. But we multiply 8. So therefore, we have times 8x dx. Okay? It's in the form. So it is now in the form. It's now in the form 1/8 integral of, so this is our u. So we have u raised to 3/2 8x dx. So that is our du, 8x dx. So it's now in the form 1/8 u raised to 3/2 du. Okay, so apply the u to the n du. So therefore, we have 1/8 our u is 4x squared plus 1. So therefore, we have 4x squared plus 1 raised to 3 over 2 plus 1. So that is 5 over 2 over 5 over 2 plus c. Okay, so simplify this. So 2 will go to the numerator, or we can simply divide this 8 divided by 2. So that is equal to 4. Okay, and then multiply 4 times 5. So final answer, we have 1 over 20 times 4x squared plus 1 raised to 5 over 2 plus c. Okay, final answer. Next, number 5. So if we have integral of 2x squared minus 6x plus 4 over x minus 3 dx. So for this type of problem, we have rational expression. So the degree of the numerator is greater than the degree of the denominator. So we can simplify this by dividing. We can use long division, or we can use synthetic division. Okay, so just divide this. Okay, so if we divide this, we have 2x squared minus 6x plus 4. So by long division, so divide by x minus 3. Divide the first term, 2x squared divided by x. So that is equal to 2x. 2x times x, so we have 2x squared. 2x times negative 3, we have negative 6x. And then subtract. When we subtract, change the sign. So change the sign. So this will become negative. This will become positive. So therefore, 2x squared minus 2x squared. So 0. Negative 6x plus 6x. So this is another 0. So therefore, the remainder is 4. Okay, so therefore, this is the same as integral of, when we divide, the quotient is 2x plus the remainder. Plus the remainder 4 over the divisor x minus 3 dx. Okay, so if we have this type of problem, just divide. So now distribute. So therefore, we have integral of, we have constant of 2. So 2x dx plus we have constant of 4. So 4 integral of dx over x minus 3. Okay, so we have direct formula for this. The exponent is 1. So u to the n du, x to the 1 dx. So therefore, the answer is 2 times x, 1 plus 1. So 2 over 2 plus, so we have direct formula. U is x minus 3. The differential of x minus 3 is dx. So it is in the form integral of du over u. So therefore, the answer to this term is 4 ln of x minus 3 plus the constant of integration c. So therefore, final answer, just cancel out this. So therefore, the final answer is x squared plus 4 ln of x minus 3 plus c. Okay, final answer. Number 6. Okay, number 6. So we have integral of 2x plus 3 dx over x squared plus 3x plus 4. So we don't have exponent here. So what are we going to do here? So we cannot divide. We cannot divide because the degree of the numerator is less than the degree of the denominator. So let's try u as the denominator, because it is 1 greater than the degree. And remember that when we get the derivative, the degree is 1 less than. So let's try u is the denominator. We have x squared plus 3x plus 4. So try natin denominator. And then differential is equal to derivative of x squared. So that is 2x. Derivative of 3x is plus 3. Okay, so ito na siya. 2x plus 3 and then multiply it by dx. Okay, so therefore, it is now in the form integral of 2x plus 3 dx. So that is our du. And then x squared plus 3x plus 4. So that is our u. So therefore, the final answer is ln u plus c. But the value of u is x squared plus 3x plus 4. Therefore, we have ln x squared plus 3x plus 4 plus c. So this is our final answer. Okay, numbers. Next number 7. Okay, so for number 7, we have x raised to 1/3. So this is exponent. X raised to 1/3 plus 1 raised to 3 over 2 all over x raised to 2/3. So again, 1/3, 2/3 are exponents. Okay, so in this type of example, we will let the base as our u. Okay, so this is our base, x raised to 1/3 plus 1. Okay, so always choose the u as the base. Okay, so we have let u is equal to x raised to 1/3 plus 1. Then get the differential, du is equal to, apply the power rule. So we have 1/3 x raised to 1/3 minus 1. Okay, so 1/3 minus 1, that is negative 2/3 dx. Okay, so if we simplify this, put this in the denominator. Put this in the denominator since we have negative exponent. So therefore, we have du is equal to dx over 3, then x raised to 2/3. So as you can see, this is our, it is dx over x raised to 2/3. Dx over x raised to 2/3, but we have 3. So by simple substitution, we can multiply both sides by 3 so that this can be now transformed into this. We have integral of x raised to 1/3 plus 1. So that is u. So we have u raised to 3 over 2. And then we have dx over x raised to 2/3. But we have 3. So multiply both sides of this by 3. So therefore we get 3 du is equal to dx over x raised to 2/3. Okay? So this will become dx over x raised to 2/3. So we have times 3 du. Times 3 du. Okay? So it's now equal to 3 integral of u to the 3 over 2 du. That is by substitution. So another is by neutralizing factor. Our neutralizing factor here is the inverse of 1/3. So magiging 3 naman yung ating neutralizing factor. Okay? So therefore, this is now equal to 3 u raised to 3 over 2 plus 1. So that is 5 over 2. So over 5 over 2 plus c. And then, so just put 2 in the numerator. So multiply it by 3. So 2 times 3, we have 6 over 5. And then our u is this term, x raised to 1/3 plus 1 raised to 5 over 2 plus c. So final answer. So ang trick natin dito ay always use u as the expression with the exponent. Ayan. So in the parenthesis, 3 over 3 raised to 3 over 2. Okay? So number 8. So we have integral of dx over x times ln squared x. Okay, so anong ililet natin na u dito? So we will let u here as the term with the exponent. So term with the exponent is ln x. Okay? We have ln x. Since we only have two formulas for now, u to the n du and du over u. So we will let u as the term with the exponent. Ayan. Okay? So just simplify. So this can be written as integral of ln squared. So we put that in the numerator. That will become ln negative 2 raised to negative 2 of x dx over x. Okay? Then we will let u is equal to ln x. Not include, the exponent is not included. So ln x. So therefore we have differential of ln x is 1 over x times dx. Okay? So which is this term, dx over x. Okay? Dx over x. So du is dx over x, which is this term, dx over x. Okay? So it's now in the form, integral of our u is ln x. So this is ln x, so our u. So this is our du dx over x. This is our u ln x, and this is our exponent n, negative 2. Okay? So therefore, that can be written as u to the negative 2 dx over x, so that is du. Okay? So if we integrate that, that is equal to u to the negative 2 plus 1. So negative 2 plus 1, that is negative 1 over negative 1 plus c. So let us simplify, put back the negative exponent in the denominator. So therefore we have negative. So negative 1 over u to the 1, or simply u, plus c, and then put back the value of u, which is ln x. So therefore we have negative 1 over ln x plus c. So this is our final answer, negative 1 over ln x plus c. Okay, next, number 9. Integral of dx over e to the x minus 1. So for this example, this is tricky, because if we let u as there is no other term, e to the x minus 1, our du will become derivative of e to the x is e to the x dx. But our expression is only dx in the numerator. We don't have e to the x. So by direct substitution, of by letting u equals e to the x minus 1, that is not very effective, because we cannot reduce this in the u to the n du or du over u. So we will find another way in solving this. So to solve this, we need to multiply both the numerator and denominator by e to the negative x. Okay, so once you this type of problem wherein we only have 1 e to the x, we will multiply that by e to the negative x. The exponent of this is e to the x, so multiply by e to the negative x. Okay, so this will become integral of e to the negative x dx, the numerator, over, let's distribute e to the x times e to the negative x, so that will be equal to 1, because e to the x and then x minus x, that is 0. E to the 0, that is 1. And then multiply negative 1 and e to the negative x, so that is minus 1 e to the negative x. Or simply, let's do not write the 1. So 1 minus e to the negative x. So now, if we let u as the denominator, so we have 1 minus e to the negative x, and now the differential is equal to differential of 1, that is 0, differential of negative e to the negative x, so just multiply this, negative times negative, so that is positive e to the negative x. E to the negative x, and then derivative of negative x is negative 1 times negative, so that is positive na. Then we have dx. Okay, so therefore, it is now in the form, so by substitution, we have integral of e to the x dx, that is our du. So we have du over 1 minus e to the x, so that is our u. So it's now in the form du over u. So therefore, it is equal to ln of absolute value of u plus c. And then the value of u is 1 minus e to the x, so therefore we have ln 1 minus e to the negative x plus c. So final answer. Okay, so that's how to solve this type of problem with one e to the x in the denominator. So just multiply. We just simply multiply this by 1 because e to the negative x over e to the negative x is 1. Okay, last example. Number 10, we have integral of square root of tangent 3x times secant squared 3x. So if we have trigonometric function, inspect the trigonometric function if the other is the derivative of the other. So as you can see in this, we have tangent and secant square. The derivative of tangent, remember, the derivative of tangent is secant square. So it's in the form u to the n du, because our u here is tangent 3x. Tangent 3x. Our differential of tangent 3x is derivative of tangent is secant squared 3x times derivative of 3x, we have 3 dx. Okay? So therefore, it is in the form, So we have neutralizing factor. So let's use again the neutralizing factor. Okay, so neutralizing factor, we don't have 3 in this expression. So we in our differential, we have 3. So therefore, the neutralizing factor is the inverse of 3. We have 1/3. So therefore, this can be written as 1/3 integral of tangent 3x. So we can write that as tangent 3x raised to square, that is square root. So that is raised to 1/2. And then we have, so let's write this 3. So times 3 secant squared 3x dx. Okay? So that it is now in the form 1/3 integral of tangent 3x. So that is our u. So that is u raised to 1/2. And then 3 secant squared 3x dx, secant squared 3x dx. So that is our du. Okay? So therefore, the answer is 1/3 times integral u to the n du. So just add 1. So we have u 1/2 plus 1, that is 3 over 2 over 3 over 2 plus c. So therefore, simplify. So 2 will go to the numerator. We have 1 times 2. So that is 2 over 9. And then the value of u is tangent 3x. So therefore, we have 2 over 9 tangent 3x tangent 3x plus c. So the exponent is 3 over 2. So just write the exponent 3 over 2 beside the tangent. So this is our final answer. 2 over 9 tangent 3 over 2. Ayan. Tangent 3x raised to 3 over 2. Okay, so that's it. So I hope you're satisfied with my solution of by simple substitution and by neutralizing factor. So we have two solutions. So that is the same. One is by neutralizing factor. One is by dividing both sides by this term, divide both sides by 3. So that therefore we have du over 3. du over 3. So same answer that we will get 2 over 9 tangent raised to 3 over 2 3x plus c. So thank you for watching and see you on our next session. Bye-bye and God bless.